Guys, Daniel here, aka HashLips, and welcome to the second part of creating an NFT with IPFS tutorial. In this part, we already have created the smart contract on Remix, so now we're going to be focusing on the front end dApp that we have to create in order for us to upload a canvas to the IPFS and then mint it on our smart contract. So that's what we're going to be doing, and to make it a bit more easier for ourselves, I've created these repos on Github. So if you would like to go to github.com/hashlips, you will find all these different repos, and these usually go with a tutorial that I make on YouTube. But one of the ones that's pretty cool is this front-end based dApp, and we're going to be using that as a kickoff process for any of the projects going forward. The reason for this is because I don't want to re-illustrate and recode all the stuff that we've done in the NFT game. So in any point of this repo, this based repo, if you don't understand anything, for instance, if you don't know exactly what the folders do, feel free to go and check out the NFT game tutorial. You will exactly know what I'm talking about then, because I explain it explicitly there. But going forward, you would need from this point on Ganache Cli installed, Truffle, the Truffle suite installed, and npm node and yarn, just to get you started with this next part. So I'm not going to install that, but that's the dependencies you're going to need. So let's get started. So what you want to do is let's click on the front-end base dApp. And once we've opened it, you can see that it's a little repo. You can click on the code button and copy it. The next thing you can go ahead and do is open your favorite IDE. I'm using Visual Studio Code for this, but you can use anything you want to. In the terminal, go to the directory that you want to save this project in, and then just type in git clone and paste in that link that we just copied. This will go ahead and download the base dApp and the base front-end dApp for that matter. Now the front-end dApp that I have over here has a few different things that I'm going to go through, but in essence it sets up the connection to MetaMask. It creates a space for you to put the smart contracts and hook them up to the blockchain. So it makes it much more easier to write smart contracts, spin up this front-end dApp, and then connect everything. It will also make your development speed much faster. All right. So once you have this, I recommend reopening the folder in Visual Studio Code. For now, we're just going to cd into the directory. So you can type in cd front-end. Let's do this front-end dApp. And now we should be in this directory. You can just verify that by typing in ls, and yes, indeed we are. So the next steps that you want to do, like any project that you get from GitHub, is initialize all the dependencies by running yarn in add all or npm install. The dependencies that we are going to need is all listed here in the package.json file. So let's go ahead and do that. I'm going to be using yarn. So I'll just do this, yarn add all, and hit enter. This will now download all the dependencies we need. And while that is downloading, I'm just going to quickly take a second to show you the next part that we also need to set up. So the next part is the program called Ganache Cli. And Ganache Cli you can download, and basically Ganache allows us to spin up a local blockchain right here on our computer. And how you would do that after you've installed Ganache, you can just enter Ganache-CLI. And once you hit enter there, it will spin up a blockchain, and you can see a bunch of information on what it's busy running. Ganache is also nice enough to give us a few addresses that we can use, as well as their corresponding private keys. And this is important because we actually need to connect one of these accounts at least to our MetaMask so that we can use it in our dApp. Next, while this is still installing, I'm going to quickly show you how to set up MetaMask, the RPC for this test network. So if you scroll down to the bottom in your terminal, this could be a global terminal by the way, you can see that it's running on port 8545. And we have to make sure that that's the same port that's sitting in our truffle config file, which we'll verify just now. But also this is the endpoint that we're going to be using for our RPC. So let's go and set up MetaMask. What you want to do is head back to your browser, open up the MetaMask extension, and go ahead and add a network. So you can click on the network tab here at the top, scroll down till you see custom RPC, and then go and enter a network. We're just going to start off with saying this is the test network. We're going to give it the endpoint that we've seen in the terminal, which is this 8545, and then the chain ID we're going to make 1337. This is the usual information for Ganache and how we're going to connect to it. Once you've set this up, you can go down and hit save. MetaMask will automatically put you now on that network, and you can see that the account in here will have 0 ETH. This is fine because we don't have an address on that network yet. So basically we just want to connect to that. If you're not connected to the test, just make sure that you are. And the next steps that you want to do is actually open your terminal again and go and find one of the private keys. So here's one of the private keys for the address. We're going to copy that. We're going to head over back to MetaMask, click on the icon and click import account. We're going to paste the private key there and say import. Now you will see that we have 100 Ethereum basically in this account because it's connected to this local blockchain that's running over here. And that is it. We have a setup that's successful. This is all installed, so we're ready to go. Let's close this package.json and let's quickly see if we can run this dApp. In order to run this base dApp, it's very simple. We have smart contracts here in the folder structure. As you can see, we have the normal migrations, which is always there. And then we have the smart contract.sol. Smart contract.sol sounds familiar, and that's because we've used it in our remix. We're going to be replacing that contract here very soon. But what I want you to understand at this point is these smart contracts are just the .sol files. They're not on this local blockchain yet, and we need to get them there. And we can achieve this. And remember, we want to actually get this on this terminal local blockchain. We can achieve this by running truffle migrate -- reset. Now, the reason why you want to add the -- reset is because if there was any previous smart contracts that got migrated, it will replace them. Just for a brief second, I'm just going to show you something in the truffle.config file. So if we click there, we need to make sure that in our development section up here that we have the same port that's running in our terminal. And indeed we do. So everything is good over there. And next, let's just make sure that in our compiler section that our version is 0.8 for the compiler, and that we have this line on line 83 saying that we want to have the build go to the source and into the contracts folder. So the reason why I have a second contracts folder is because the one in source, if I go into the folder structure here and I go to the one in source, the contracts that are in here are the ones that getting deployed, the ones that migrated. We can actually remove all of these ones because we're going to do a new migration. You don't have to remove them. It's just for this demonstration so you can see what gets migrated. So this contracts folder now here in the source file is empty and we're ready to go. So let's hit this command in the terminal and let's migrate our smart contract on the blockchain. If you open this local blockchain as well, you will see that it also starts kicking off transactions. And that's going to be because the smart contract basically being migrated to the local blockchain. And there you can see there's the transactions. And if we go back to the terminal, you can see that this was successful. Okay. And there we go. This was basically deployed. And if we open the source contracts folder over here, you can see there's two new files, the migrations, which is corresponding to those migrations. But indeed, we have our smart contract.json. And this is an important JSON file. This file holds the ABI to our whole smart contract. And an ABI is telling the person using this or the machine using this it's actually giving you just an interface to use to the smart contract. It defines things like the functions that the smart contract has. And that's about it. So what I'm going to be doing is closing this folder. We don't need to have that open. The next thing we can do is just to run as our testing our application and see if it's going to run. So I'm going to do that by running yarn start. So if you run yarn start, this will now spin up a local also development server, but this is going to host the files of the React app. And remember, the React app is set up in such a way, if you followed the previous game creation tutorial, you'll see exactly kind of the similar way this dApp is working. It asks us to connect, and if we, for instance, go to MetaMask and we switch to a different network, for instance Ethereum, we can go to Ethereum, but if we try and connect, it will tell us to change to Polygon, and that's exactly what we want to do. So let's go and change. We're not going to change to Polygon. This is basically pointing to our test network, so technically it wants us to be on the test network, and we can see that our Ethereum went down. That's because we actually migrated this smart contract, right? So this is all test Ethereum, so just as a side note. So now that we've swapped networks, we can say connect. And look at this, we are inside our dApp. This is the base dApp. It basically has a name, and I'll show you now where we get that from. But basically our dApp's working and we're ready to code along, implementing the IPFS and bringing over our smart contract from Remix and taking this tutorial to the next level, where you guys will now find out how to do all the IPFS wonderfulness, right? Cool. But just before we go, I said I'm going to show you where that smart contract comes from, and that's coming from here, the name, okay? So it's coming from smart contract, which is defined in our smart contract as a public variable in our smart contract. And when we look through the rest of this file, we've got our contracts up here, our migrations, and our node modules, and our public folder, which is all normal React.js code. The rest of the stuff is a bit more extensive, so I'm going to quickly run through this. But once I'm done here, you will be in a good space to follow along. Okay, so in the source directory, we can open the source directory, and this is the kind of the heart of the application. This is the heart of any React application. You usually see this structure in place. Some of the things are new, but we have explained this. The contracts folder holds the migration files, the JSON files, telling our app how the ABI looks like. The Redux folder over here holds a bunch of folders and a store. Now, a store is set up in our application, which uses a configure store function to actually configure and pull together all of our reducers. If you do not know what Redux is, it's good and actually a better way to go and store state in your application and so on. But I would recommend you actually going to read up on it a bit more, watch a video on Redux if you're not sure what we're doing here, and then come back. You do not need to know Redux for this tutorial because I'm just going to show you exactly what to do and you can follow along. But basically we have two Redux states, a blockchain and a data. And then we combine them and we configure our store. Lastly, once our store is configured, in our index.js file down here, we import a provider and the store and we pass it in. This looks very familiar. It almost looks like using the context API. We are wrapping our app, which is our primary app, which is sitting in app.js, with a provider. This means any of the components inside this provider will have access to our state. And what is the state that we're talking about? We mentioned blockchain and data, and there the two are, okay? So if we open the blockchain, you can see that we have got an actions and a reducer. Similarly, to data, we have the same files, actions and reducer. But let's focus on the blockchain quickly. Let's open the reducer. Basically, a reducer is a piece of state that we want to save and have the rest of the app communicate and read this data and manipulate this data. And the data for the blockchain that we want to keep is this object over here. We want to keep a variable for loading for the current account that we're on, for the smart contract that we actually loaded up, and an instance of Web3 so we can interact with the blockchain. Perfect. Next, we've defined a few actions. Actions are just basically instances or case statements that changes the state. And you can see that we have a few actions such as connection request, a connection success, and a connection failed. When this reducer receives any of these actions, it knows what to do with the state. So for instance, if we connected successfully to the blockchain, then we will fill in all this information that we want in here with the relevant information that we pass to it. And that's basically how it works. But like I said, go and do a bit of research on Redux if you don't understand this to the full extent, but that's all you need to know. After we get a reducer, we need action calls. And these actions can be defined as little functions like this, and all it needs to pass to a reducer is a type. And this is the type that you've seen in the previous file. It's a connection, request, success, and failed. And once we call these things, it will go and change and manipulate the data in our Redux state. That's why in our blockchain actions, we have this one connect function. And I've explained this before, but I'm going to briefly explain this again. When this function is called, okay, we do a few things in this function. If you look at this function, you can see that we are returning an asynchronous function which takes in a dispatch. A dispatch is needed for Redux, and this is also making use of Redux Thunk. Thunk is there to make you Redux accept asynchronous calls, and that's the only reason why we're returning this off the bat. Inside this return statement, we basically dispatch a few things. You can see that there's an instance where we dispatch here at line 36. There is an instance where we dispatch here at line 52, as well as on line 61, 78, and also 71 and 74. These are the actions that I explained to you just now. Dispatching a connect request action will go to this function over here. It will call this, and then because it's dispatching, it will actually return the type. In our reducer, it will go and try and match which type that was. It would see that it is a connection request and actually do the following to the state. So the following that it's going to do is it's going to set everything to the initial state, meaning that it's going to set everything to false, null, 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 and an empty string. The reason why we want to do that is because if we're loading data, we don't want previous data to be there. Sometimes you do, and then you would change this to state and not initial state. But anyways, we put the loading to true, meaning that something is going to load in our application, and that we can use now in the front end, because we can connect to this state object and say, well, if this is loading, display a loader bar, and we know exactly which state is busy loading. If we go back to the actions file, we can see then going down here again, after this call, our state's busy loading currently. Then we do a call to see if there's an Ethereum provider on the browser. Now, window.ethereum, the Ethereum object will not be there if you don't have MetaMask. So the first thing that we check is if this Ethereum object is inside the window object, and if it's not, we can go down here and we can see that we dispatch another action. We dispatch this time connect failed, and we pass in a string, install MetaMask. This will actually go up here if we go to this function call, which is this connect failed. You can see connect failed takes in a payload, which was that install MetaMask string, and it goes and it chooses the type again, but then also sends the payload in here. Again, the similar process follows where it goes to the reducer, it sees that it failed, it will go and update the state. We again set it to the initial state. We set loading to false because at this time we know that we've loaded the data or something went wrong. So we don't want to show the loading anymore. We want to show an error message. And that's when we set the error message to the payload that we've passed into this function. Very straightforward, right? Okay, I'm not going to bore you guys with the rest of the explanation of Redux, but I'm going to still go through this function. After this, we can see that we have we check for a Web3, and this happens after we know that MetaMask was installed. In the newer MetaMask version, you can just do this and it will work because we pass in the Ethereum object, the provider, to Web3, and it will create a nice Web3 instance for us. Next, we want to do a few things. We want to get the accounts, and you do this by passing in these events or listening to these events basically asynchronously. So you're going to go and kick off and say, well, we want to request the Ether accounts, and this will return an array. And then we're going to save it in this variable. Then we do the same with the network ID. We get it calling the net version, passing that as a method. And then we have this variable called network data. Network data comes from the smart contract that we've actually migrated. Remember that contracts folder where we had the smart contract.json? That's exactly where this comes from. We import it here right at the top. Anyway, going on, we find that JSON, we look in the networks, and we pass in the ID variable that we found here. The reason why we want to do this is because every time you migrate, it might be a different network ID that we don't know, and we actually want to just have access to that object because that object holds the actual contract's address. And this is where we are using it. Once this is fine, and once we actually have a network data, it means that we're good to go for testing our developments. Once we get to deploying on the main network, we do change these two lines, which I'll show you on later. But the next thing that we want to do is we want to check if the network data is there, and if not, something went wrong. And then we catch it and we dispatch. If it didn't go wrong, we carry on. We create a new smart contract object, which is done by using the Web3 library now that we've instantiated. We do that and say that we want to create a new contract. A contract creation takes in two things. It takes the ABI, which can be found from the smart contract JSON.ABI, because if you open the contract smart contract .json here and you open it, you can see there's the ABI. So it's easily accessed just by going smart contract.ABI. The next thing that we want to do is get the address of this deployed contract, and that we can do doing network data.address. And then we're good to go. Then we actually dispatch the success Redux function. And the success takes in a few more parameters because these are the parameters that we want to make sure that we have a smart contract, we have someone's account that's connected to MetaMask, and that we do have a Web3 instance. It again, like I explained, goes from here, goes up to the success action, and then it goes into the reducer, calls the success, and this time it doesn't put the initial state, it puts state there, meaning that it's taking the current state and updating these variables, because sometimes we have data that's already loaded and we want to just replace them. So technically it would make sense if we set the initial state here at the request should also be state. Otherwise, it's going to clear out everything every time we load the data. But that's a discussion for a later time. Perfectly cool. So the last part of this function explanation is basically these two functions. These two functions are listeners, and you can listen for events that kicks off. What if someone changes their account, and also what if someone changes their network ID? Well, in the one instance when someone changes their account, we don't want to reload the whole page, but we're going to dispatch an update account action in Redux. And we can find that action right over here, update account. It takes in a payload, it says it needs to update the account, it goes to the reducer, it goes down here, and it just updates the account. And that's very easy. Let's go back to the blockchain actions. And then the last listener checks for if the chain has changed, and if that is so, we want to reload the whole page because we don't want to have people mess around and it's not connected to the right network. That's why we reload it rather, and then we can do all these checks again, and if the guy is not on the right network, we can inform them. And that's basically the Redux structure. I know this is a mouthful, but I'm doing this on purpose so that I can redirect you guys back to this tutorial whenever you guys are struggling. I've discussed this in the game tutorial and I'm discussing this a little bit here now again. So hopefully by this time, you guys will get Redux a bit better. For the next folder, and a very important folder, is the styles file. So the styles folder and the styles files in there are very important. I've set up these global styles reset and theme, especially for you guys to always kick off and be able to code, style, and just play around, because it's very important to not every time set up a project from scratch. It's very, very redundant and it's not very cool because you spend most of your time setting up projects. So I'm just going to briefly run through them. You can see the reset.css. This is a reset file that will reset most of the way that CSS does stuff so that we can do custom CSS. We also have a theme.css, which in the root selector, we actually define a few colors, and that's all. We import both files inside the index.js. So if you go to index.js over there, you'll see that we import them there so that the whole app has access to that CSS. We won't be using a lot of pure CSS in this application or in any kind of the stuff we do when we develop these dApps. And the reason for that is there's a better way of doing CSS when it comes to React.js, and that is using styled components. You'll see that there's a last file in the styles folder called global styles. In global styles, we import a library called styled components. And then what we do is we set up these objects, mainly screen, spacer small, spacer extra small, small, spacer media. And then we also can go down. There's a bunch of these ones. And these kind of objects act as React components in a sense. You define a component like this, and you say that we want to use the styled library to define this as a div. In there, you can actually do a string description of how you would like this div to look like, basically CSS. And once you've defined this, you can also pass properties, and you can access them like this inside a component that we can use. So we can, for instance, use the screen component and pass a prop image, and we can check if the image is there, and if it is, then we append it to the value, otherwise we don't. The same thing happens with a more complex objects that I create, like this container, where we off the bat define it as a div, we define it as displaying flex, and for the flex value, we check if there's a flex prop and we set it to that, otherwise it's 0. Same thing goes for flex direction, where we check the FD property. And if there's an FD, we actually go and use the value that we give it. This I'll explain as we go and code along, but just take that in consideration. This is what we used for styling. It's much better, it's much more reusable, and also it takes away the whole burden of creating a CSS file, adding the classes, and so on. So seeing that this tutorial also isn't focused on styling, that's why I'm using this as well. But also it's a much better way, like I explained, and I think you guys will find it very useful. So go and read up on styled components if you want to know more. Perfect. That was the last complex folder to explain. The rest is simple. We just have an app.js and an app CSS. We don't even need the app CSS, so you might as well go and delete that. Just remember then to take it out of this app.js file so that it doesn't break. But apart from that, we don't need anything now, or need to explain anything now, because here we just have a basic component, a React component. We have a bunch of imports, and I'm going to, from this point onwards, go and add the code we need to now complete the tutorial. Just before I go, remember I mentioned that styled globals component, that one with the difficult things here. We can see it in use in the app.js file. So if we go, we can see that there is a s.container. Why the s dot, you might ask? Well, that's because I'm importing everything from that styles file as the s alias. So we can easily see which styles are global by the s dot that it's appended to, or prefixed with. And then we can go and see it's a container component, basically acting like a div, because in the back of it all, this component is a div, so it will behave like a div, but it has these extra properties and styles on it, and it can also take more properties. And you can see this in action where I pass in a prop of flex, I do an AI equals center. AI stands for align items, and JC stands for justify content center, right? It just makes it easier to do it on the fly, on the spot, if we want to quickly use flex values to position things. And you can see here's all the rest of the other global styled components as well. This is the simple example that you just saw when we were playing this blockchain dApp. So you can see there's a gray background with just this name, but there's also much more happening. If we refresh it, you can see connect to the blockchain with the connect button. And this is all happening just here on this file. Here you can see that's the first part. And if these conditions are met, if the blockchain has an account, if the blockchain has a smart contract, then it's going to show that we are logged in, right? So we're going to display the name, and the name we get from our data field. We haven't discussed data in the Redux part. We have discussed the blockchain part in the Redux, but basically the data part, similar to the blockchain part, all it does is it has different reducers and different actions, but these actions are used to make sure that we connect and actually read data of our smart contract. So the functions that I kick off here, for instance, let name equals await, we actually go and kick this off based on our blockchain. After it has a smart contract connected to it, we go and call the method, and we're going to call name, right? And that's basically how we get the name. We save it and we dispatch it so that we can update that, and then we read it in our app.js. But that, I think, is enough explanation for the start of this, because now we have the real work cut out for us, and that is to alter this app.js file, import our contract, test them, and that's what we're going to do right now. Now we're at the point where we're going to start pulling over our smart contract into this base dApp so we can actually get coding and see some results. So what you want to do is head over back to Remix and then go and select everything that we've typed out up until all these imports, this Open Zeppelin import. Perfect. So now let's go back to our IDE, and if you open the contracts folder, you can see that the smart contract.sol is already there for us. If your contract is named differently, you need to rename it there and just do exactly the same that I'm doing here. Paste our smart contract in there. You can save this. And also, if it's another name, just remember to upgrade your migrations file over there and these few spots. Right? Perfect. Let's head back over to our smart contract. Everything looks perfect. You'll notice that there are underlines here. Your IDE might do this or might not. This is a mistake of the IDE because it can actually pick up the node modules. I don't know why it's moaning right now, but it shouldn't be doing that, and I can prove that if I close the file, everything is normal until I open it again. But you can basically close your IDE and open it again, and it should be fine. I'm not going to do that because we want to continue with the tutorial. Next, just to make sure that everything can deploy successfully, we want to run the command truffle migrate -- reset. So in the terminal, we're going to run this. This will actually migrate our new smart contract that we pulled in from Remix onto this local blockchain. Perfect. And we can see that everything went successful. There's our summary and there's our smart contract. So now that everything is set up, we're technically ready to rock and roll and do the front end and deploy our app, right? Well, cool, we can do that. But some concept that I haven't explained before, and I'm going to briefly touch on, is actually doing tests, unit tests for your smart contract. Now, we can test our smart contract using Chai, and it's very important to write these tests because once you publish onto the blockchain, you cannot change it, right? And then it's a problem if there's a problem in your code. So let's go ahead and do that. We're going to close this the smart contract file, and we're going to go down to this folder called test. And inside this folder, there's a file called smartcontract.test.js. You might see that your file already has some test in it, but we're going to write it out here so you can get used to writing tests and see how easy it is. The first thing that we're going to need is firstly an artifact and the Cli library, and that's these two things. So basically we are importing the artifacts from the contract folder instance, and we're saying that we are going to be using the smart contract. Then we're importing Cli and saying that we're going to use Cli as promised and import that as well. This is going to be our library that we're going to be using to do tests. And to start a smart contract kind of test, it's pretty easy. We can just say contract, right, like this. Hopefully it doesn't, the IDE corrects it. So just say contract, small letters, that is fine. Let's just define the smart contract's name. So we're going to say smart contract, and then you have to pass it basically a function. So this arrow function, what it does is on build, and when you run this test, it's actually going to run an instance where you can have some parameters that gets passed through here. So you can basically go and extract the different accounts that gets passed into this this function as arguments, if I can put it like that. But anyway, maybe just call this accounts, okay? Because later on we can use these accounts in the test that we're going to write. So open the brackets, and now we're halfway there. Before we start, we need to kind of set an instance for our smart contract, the artifact that we want to use up there, right? So what we want to do is we want to actually say let smart contract, like so, is going to be equal to nothing for now. Okay, going to make it null or whatever you want to do. But what we need to do is, before our test run, we would like to make sure that our smart contract is deployed. So we can have a before statement. Before, I don't know why this stuff self-corrects the whole time. And we need to pass in a function here, which is pretty cool. And that's about it, right? So we need to close it like so. In this function, we can say that, well, our smart contract should be equal to awaiting this. So because this is an await function, you need to make the actual function async. So we're going to do that. So we're going to await, and what do we want to wait for? We want to wait for the smart contract to be deployed. So we're going to do that. Perfect. So now what this code is saying is that before the test run, make sure that our smart contract is deployed, so that anything that we do now is something that can make use of the smart contract instance. And that's it. That's the start of our code. Let's just run the test. And what you can do is in the terminal, you can say truffle, and instead of truffle migrate, you can just say truffle test. And hopefully this will work in some way. There's no test to be ran yet, so we're just going to see it compile and passing. Everything looks fine, right? Nothing is passing because we don't have any tests. And now that we make sure that we have a smart contract instance, we can start writing our first smart contract tests. And what you do is you follow a logical order. The first thing that you want to do is you want to describe. Okay, we want to describe a heading kind of for our test, and we're going to describe the deployment. Okay, so we want to describe the deployment. We're going to make an arrow function, and basically you want to do this asynchronously. And the reason for that is because we're going to await a bunch of stuff. So apart from the deployment, we're also going to need a description for minting, right? Because we want to test the deployment section, and we also want to make sure that our minting is also working. So we have those two functions. Let's open up the deployment description first, and let's do some tests to make sure that you know, this thing ran. So the first thing that we want to do is define how can we make sure that our contract instance is actually there. Now, one thing we can have a look at is the smart contract address and see if that exists, right? So now what you can do in your tests is say it, and this is now defining what it should do to be successful, right? So we can now say, well, it deploys. Okay, so it deploys successfully, and then again with the asynchronous function, so arrow function. Okay, so basically what this is now going to say is that we want to make sure that our smart contract has deployed and our instance is ready for us to use. And how can we do that? Well, we can create a constant variable and call it address. And we can equal the address to the await, okay, of the smart contract instance. Now, we are targeting the one that we've deployed over there. So this variable, right? We're going to see simply, we're going to await its address. Now, you have to add the await keyword because this is asynchronous. So once we awaited it and the variable exists, then we're going to run our test. And how you do it is by saying assert. Okay, and you might have noticed that Assert also added a library here at the top, Assert. So yeah, we should have imported that. So just make sure you have that. But basically, we're going to say assert.not equal. And basically what we're going to say is that we need to make sure that our address is not equal to, well, first of all, it shouldn't be empty. And then the next thing is we can also say that it maybe should not equal. So you first put the parameter that you want to test, and we want to say that it's not equal to 0x0, meaning it is the 0 address. But anyway, we want to make sure that that is fine, and if it is, it means that this test is successful. Our deployment was successful and it deploys successfully. So let's run our test. We can go to the terminal again and run truffle test, and this time we should see one test passing at least, which should be our deployment test. And there we go. So we can see, so our contract, smart contract, our test deployment, and it deploys successfully based on this. Now you can put as many its in this description if you want to. That's enough for us to just make sure that our test work. The next test is much more important because we want to actually see if we can mint a NFT and that the user's kind of count increases. How can we do that? Well, first of all, we have a description. So now we need an it again. And in the it, we're going to give it a name, and we're also going to give it an arrow function. And the arrow function is going to be async, right? Remember that. Now, we also want to say, what does this it do? We want to test if it minted. So if this minted successfully, then everything should be fine. On what conditions? So now open your brackets, and we need to define a few variables. So first variable I want to define is the URI. Now we don't have a URI yet, the IPFS URI, but what I'm going to do is just say, well, https / example, right? Just like that. Maybe it's example.com. We can call it whatever we want to, but that's just a test for us to mint our NFT with. Next, what we want to do is we also want to define another variable, which we actually want to call what? Token URI. So token URI. And the token URI we need to now get after we mint it. So let's just leave this variable empty for now. Let's go and create a space between these two variables and actually await our smart contract. So now what we're going to say is smart contract.mint. Now, where do we get that from? If you recall, in our smart contract, we actually have a function mint, and that's taking a recipient and a URI. And that's very easy. So we can go back to our test, and where we have our minting now, and we say mint, we need an address. So remember this accounts that you have here at the top. Basically, all you have to do is you have to say account, and we want to specify the account 0, which means it's the first account in the array. And then we want to give it the URI, the one that we've defined just here. And that's all that should be needed to mint an NFT. Perfect. So after we've awaited this smart contract, right, for it to mint, we can actually now get the token URI. How do we do that? Well, again, back in our smart contract, we have this function called token URI, which takes in a token ID. Now, if our smart contract minted this NFT, it should have minted the token on ID 0. So basically what we can say is we want to await this smart contract dot token URI, okay, and I think the function is all caps. We'll have to just double check that, and yes, let's just make sure token URI, perfect. And we want to actually check ID 0. So that will happen if our token minted successfully. This will actually have a value of whatever URI was saved, which should be this. So now our test is fairly simple. The last thing that we also just need to get before we do our test is the balance of the owner, right? So we need the balance of the owner here to make sure that it's also increased by 1. So what we can do is we can await the smart contract again, and then what happens is we can call a function that's sitting in our smart contract but under the ERC 721 interface, which is already defined, which is basically called balance of. And the balance of takes in an address. So because we have minted to the account 0, we can then say, well, we want to again check the accounts 0. So what we are expecting is for the token URI to actually have the valid URI that we've defined up here after the minting has happened, and for the balance of the owner to actually be 1, because one NFT should be owned by that address at this point. Okay, so now we can go ahead and do our tests. Now, how we can test this is again use the assert, and after the assert we can now just say, well, if this equals takes in 2 parameters to see if they equal each other, obviously. So we're going to put in the token URI, and we're going to say, well, this should equal the URI that we specified up here, right, after the minting has taken place. So that should be a test. And we also want to assert if something is equal again, but this time we want to say if the balance of the owner is equal to 1. Okay, and that should make our tests pass, because now we are checking our minting and we're also seeing if our smart contract is deployed successfully. Let's run this test and see what happens. So let's go down in the terminal, run truffle test. Let's wait for it, and we should see 2 tests passing. Perfect. Now you can see that the minting passed successfully and this deployed successfully. I would just like to give you an example if one failed. So if we change the balance of owner to 0, meaning that something went wrong basically, right? Then let's just run it again. So we change it to 0, save it, run truffle test. And I just want to give you an example of how a test looks like if it fails. Perfect. And now you can see that the minting didn't go successful because we were expecting 0, but we got 1. And that is correct. We wanted 1. So that is perfectly fine. Guys, thank you so much for listening to this tutorial and actually writing the tests, getting the smart contract up and running. I know this video is probably a bit long, so I'm going to end it here. And in the next video, I'm going to show you how to now set up the front end. And this is really the part that we've been waiting for, but I believe in doing proper tutorials so that you know what you are doing when you are creating apps with me. So if you've enjoyed this video so far, please go ahead and like all the videos. I really would appreciate that. Leave a comment in the section below and then just subscribe, because I appreciate you guys a million times. Thank you so much, and I'll see you in the next video.